Okay, so we are on page 5 of our Chapter 8 Lessons 8.3 Scale Diagrams. You guys don't have these diagrams in your notes, but just to kind of see how scale diagrams relate to in real life, you may have bought a souvenir if you've been to France, like the Eiffel Tower or something like that. Here's an example of how scale diagrams come into play, or if you ever collected something like model trains, they are created to a certain scale from the original actual train. Also in socials class, or if you're traveling somewhere, you may have to read a map, and in this corner right in the bottom left side we see a scale here. Also, other classes you may be taking, like biology, sometimes you have images that are enlarged in order for you to see the details, things like cells and molecules and things like that. So here we go. We start with some definitions, so we'll just read through these. A scale drawing is a reproduction of a diagram. It is either larger or smaller than the original, but it has the same shape. Each dimension of the figure is multiplied by the same scale factor. In order to visualize the actual figure, you need to know the scale of the scale drawing. You'll need to use ratios and convert measurement units. Okay. So it says here the scale of a diagram can be specified in 4 ways. We see a statement, a rate, ratio, linear scale, which we quite often see on maps. We will quite often be given information in a question, which we will then turn into a fraction so that we can make a calculation. When we use a formula that we'll be given in the next little bit, what we have to remember that when we use the value that's on the top relates to the image, the model, the diagram, whatever you have. So if you have something that, let's look at this example, we have 1 centimeter to every 50 kilometers. This could be a good example of a map. So if we have 1 centimeter on a piece of paper, that could relate to a map of BC, which is a lot larger, could be drawn in kilometers. Size of the actual object would be written second. Okay, so we're told here if the image length is larger than the object length, then the scale factor is greater than 1. So yeah, and we have an enlargement. If the image length is less than the object length, then the scale factor is less than 1. And we have a reduction. We don't have a negative value, but we would have a decimal. So example 1 over 4 is 1/4, or 0.25. That would be a reduction. Okay, here's the formula that will be used to calculate scale. We have image size over top of the actual size. If we are given other information, we may be asked to calculate the image. In that situation, we are given the scale and the actual size of the object. Or if we got the image and the scale factor, we could then figure out the actual size of the object. Okay, so let's look at a couple of examples. We'll fill out the table, and we see the formulas down below that we would be using. So first of all, if you look at the very first row, 7 centimeters, 14 centimeters, we see that what we're looking for is a scale factor. If we're looking for the scale factor, we must be using the first formula, which is image over the actual. So as we see, 14 is the image, 7 is the object length, and we see the scale factor is 2. And remember, we said that a scale factor greater than 1 is an enlargement. Next one, we have the same information, so we're using the same formula. This time we have 5 over 15, which is equal to 1/3, which is equal to 0.3 repeating. And that is a reduction, because it is less than 1. Okay, next. We're already given the scale factor, so we can simply answer the last part of this row. 1.5, is that greater than 1? I believe it is, so we have an enlargement. Okay, so let's look at object length. Object length is the bottom one. We're looking for the actual size of an object. So we have image over top of scale, 6 over 1.5, and we get the object length is actually 4 meters. The last one, we also have the scale factor, so we can fill in the last part of this table, the last column. 0.4 is less than 1, so we have a reduction. To determine the image length, we use the middle formula, scale multiplied by the actual object length. 8 times 0.4 is 3.2 feet. Okay, next example here. We are told here that surveyors are using a measuring device called a tight chain to determine boundaries of plots of land. These two surveyors determined that a proposed building site is rectangular, measuring 175 meters by 50 meters. So that's the actual size. To make a scale drawing of this site, they used a scale of 1 to 2,500. So obviously if they're making the drawing, it's going to be much smaller, right? So what are the dimensions of the scale of the drawing of the building in centimeters? So here's the formula we'll be using. Image equals scale multiplied by actual. First of all, what we should consider is what these numbers mean in centimeters. 175 meters is equal to 17,500 centimeters. If we are going to get the image size, well, what we do is we multiply the actual. It is actually 17,500 centimeters. We just changed the unit, and then we multiply it by the scale, 1 over 2,500, and we get 7 centimeters. We do the same thing with 50 meters. 50 meters is equal to 5,000 meters, 5,000 centimeters. Centimeters are missing there. Sorry, guys. And we see that if we multiply 5,000 by 1 over 2,500, we get 2 centimeters. And we should answer the question like this. The question asks, what are the dimensions? So to get full marks, you should have a final statement like that, make it stand out. You're also asked to draw this on your next page, so I think we're all pretty capable of drawing a rectangle that's 7 centimeters by 2 centimeters. And that is where we will stop right now. We will continue on halfway through page 6 on our next lesson.